we'll start by reviewing how to factor the sum of two cubes. The sum of two cubes can be factored into the product of a first-degree binomial and a quadratic trinomial. So this is slightly more complex than the sum and difference of two squares. So let's say we had two cubes, x cubed plus a cubed. This would be equal to x plus a times x squared minus xa plus a squared. I recommend that you commit this formula to memory. It will make factoring the sum of two cubes a heck of a lot easier. And let's break this formula down a bit more so it can become that much clearer. Here we have the sum of two cubes. This sign will always match the sign in the first factor. So if you're adding the two cubes, your first factor will be the cube root of the first term plus the cube root of the second term. See that? The next thing you'll notice, the second sign in our factors, first sign, second sign, will always be different than the sign being used in the original polynomial. So the first sign is the same as the one in our polynomial. The second sign is different than the one in our polynomial. And the last sign is always positive. So again, x plus a times x squared minus xa plus a squared. First thing to keep in mind are the signs. Now before we get into an example, let's first review a few perfect cubes. This will help you get familiar with the types of numbers that you are likely to encounter in these problems. 1 cubed is equal to 1. 2 times 2 times 2 is equal to 8. 3 times 3 times 3 is equal to 27. 4 cubed is equal to 64. 5 cubed is equal to 125. 6 cubed is equal to 216. I would suspect that most of your problems are going to end around here, but you should know at least through 10, I would recommend, ideally 12. And I think it's unlikely that you'll get a question from your teacher that goes beyond this, because then the numbers just get so high that it's not even beneficial to testing your knowledge of the subject matter. But again, I would recommend at least knowing through 10, ideally through 12, and you should be covered. 7 cubed is 343. 8 cubed is equal to 512. 9 cubed is equal to 729. 10 cubed is equal to 1000. 11 cubed is equal to 1331. And 12 cubed is equal to 1728. Now these are all the positive cubes. If you have negative, the final cube will be negative as well, since you're multiplying the factor 3 times. A negative times a negative is positive, but when you multiply it times a third negative, the final product is negative. So let's now take a look at an example. Let's say you were asked to factor and check the answer for x cubed plus 8. How we go about factoring the sum of two cubes. Step 1, add the cube root of each term to the first factor. So the first term is x cubed. The cube root of x cubed is equal to x. So x is in our first factor. Then we have positive 8. The cube root of positive 8 is equal to 2. So x plus 2 is our first factor. And now the second step, we want to add the square of each cube root to the second factor. So the cube root of the first term, the cube root is equal to x. So when you square that, you get x squared. That'll be the first term in our second factor. And then we want to add the square of this cube root as well. The cube root of 8 is equal to 2. When we square 2, we get 4. We'll place this at the end of the second factor. And now step 3, add the negative product of the cube roots to the second factor. That'll go here. So it's the negative product. So we have x times 2, which will give us 2x. So here in the middle, we want the negative product, which would be negative 2x. So when we factor x cubed plus 8, we wind up with x plus 2 times x squared minus 2x plus 4. And I place the negative product of the cube roots in the middle so that we have this trinomial in standard form. That is why I did it that way. But technically x squared plus 4 minus 2x is the same thing. I just like having the second factor in standard form. Now, step 4, you can check the answer by multiplying the factors here. And we should wind up with x cubed plus 8 as the final polynomial. So when we multiply the factors, we get x times x squared, which is x cubed. X times negative 2x is negative 2x squared. X times 4 is positive 4x. 2 times x squared is positive 2x squared. I'll place that down here since these two terms will wind up canceling each other out. 2 times negative 2x is negative 4x. I'll place that here since these two terms will cancel each other out. And 2 times 4 is equal to 8. So we are left with x cubed plus 8 as our final polynomial, which confirms that x plus 2 is one factor, and x squared minus 2x plus 4 is our second factor. So that is how you would go about factoring the sum of two cubes. Let's now have you try a few practice questions. Question number 1. Factor x cubed plus 64 and check the answer. Question number 2. Factor 8x cubed plus 27 and check the answer. Question number 3. Factor 64x cubed plus 125 and check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given x cubed plus 64. Step 1, add the cube root of each term to the first factor. The cube root of x cubed is equal to x, so x is a part of the first factor. Our second term is positive 64. The cube root of 64 is equal to 4. 4 times 4 is 16, times 4 is 64. So 4 is the second term in our first factor. So our first factor is x plus 4. Now, step 2, we want to add the square of each cube root to the second factor. The first cube root is x. When you square that, you get x squared. The second cube root was 4. When you square that, you get positive 16. Place that at the end of the second factor. Step 3, add the negative product of the cube roots to the second factor. The product of the cube roots is x times 4, which is 4x. So the negative product is negative 4x, and we place that in the second factor. So when we factor x cubed plus 64, we wind up with x plus 4 as one factor, and x squared minus 4x plus 16 as our second factor. And now step 4, check the answer by multiplying the factors. When we do so, the final polynomial must be x cubed plus 64. So we multiply the factors, we get x times x squared, which is x cubed. X times negative 4x is negative 4x squared. X times 16 is positive 16x. 4 times x squared is positive 4x squared. 4 times negative 4x is negative 16x. 4 times 16 is positive 64. Negative 4x squared and positive 4x squared cancel each other out. Positive 16x and negative 16x cancel each other out, leaving us with x cubed plus 64, our original polynomial, thus confirming that once we factor x cubed plus 64, we will get x plus 4 times x squared minus 4x plus 16. So that is the answer to question number 1. Let's now have a look at question number 2. We were given 8x cubed plus 27. Step 1, add the cube root of each term to the first factor. Our first term is 8x cubed. The cube root of 8 is equal to 2. And the cube root of x cubed is equal to x. So 2x is the first term inside the first factor. The second term in our original polynomial is positive 27. The cube root of positive 27 is equal to 3. So our first factor is 2x plus 3. Now, step 2, add the square of each cube root to the second factor. Our first cube root was 2x. When we square that, we get 2 times 2, which is 4. X times x is x squared. Our second cube root was positive 3. When you square positive 3, you get positive 9. I'll place that at the end of the second factor. And now step 3, add the negative product of the cube roots to the second factor. The product of the cube roots is 2x times 3, which would be positive 6x. The negative product would then be negative 6x. So when we factor 8x cubed plus 27, we get 2x plus 3 times 4x squared minus 6x plus 9. And now step 4, check the answer by multiplying the factors. When we do so, the final polynomial must be 8x cubed plus 27 to confirm that we found the correct factors. So we get 2x times 4x squared, which will give us 8x cubed. Then we have 2x times negative 6x, which will give us negative 12x squared. Then we have 2x times positive 9, which is positive 18x. Then we have 3 times 4x squared, which is positive 12x squared. So these terms will cancel each other out. 3 times negative 6x would give you negative 18x. That would cancel out with positive 18x. And positive 3 times positive 9 is positive 27. So once these four terms in the middle cancel each other out, we are left with 8x cubed plus 27, our original polynomial, thus confirming that we found the correct factors, 2x plus 3 and 4x squared minus 6x plus 9. In question number 3, we were given 64x cubed plus 125. Step 1, add the cube root of each term to the first factor. So we take a look at our first term, 64x cubed. The cube root of 64 is equal to 4. And the cube root of x cubed is equal to x. So 4x is the first term in our first factor. We then look at positive 125. The cube root of 125 is equal to 5. So our first factor is 4x plus 5. And now step 2, add the square of each cube root to the second factor. So when we square the first cube root, we get 4x times 4x, which would give us 16x squared. The second cube root was positive 5. When we square that, we get positive 25, which we'll place at the end of the second factor. And now step 3, add the negative product of the cube roots to the second factor. The cube roots are 4x times 5, so the product would be 20x. The negative product would then be negative 20x. So when we factor 64x cubed plus 125, we wind up with 4x plus 5 times 16x squared minus 20x plus 25. And now step 4, we can check the answer by multiplying the factors. Our final polynomial must be 64x cubed plus 125. So we get 4x times 16x squared, which will give you 64x cubed. 4x times negative 20x is equal to negative 80x squared. 4x times positive 25 is positive 100x. 5 times 16x squared would give you positive 80x squared, which cancels out negative 80x squared. 5 times negative 20x is negative 100x, which cancels out with positive 100x. And 5 times 25 is positive 125, leaving us with 64x cubed plus 125, our original polynomial, and thus confirming that we found the correct factors, 4x plus 5 and 16x squared minus 20x plus 25.